Hello and welcome to NCC Group's Cryptopals guided tour. My name is Eli, I'll be your guide. In this video we're going to be looking at challenge 5 from set 1. This challenge involves implementing repeating key XOR. So we're going to take a plain text and XOR it against a repeating key to get a ciphertext, like so. Now this is a lot like what we did previously with single character XOR, except obviously that we're not using a single character. So yeah, let's jump in. Now, in order to do this, there's a bunch of different ways you can implement this, but my preferred method is going to be to borrow a couple methods from functional programming. And the closest that we can get to functional programming in Python is basically itertools. So we're going to use a couple of functions from here. This one is very simple. Actually, let me just pull up the itertools docs. So cycle, right here, basically if you pass it an iterable, it'll just iterate through it and then repeat once it's reached the end and go on forever like that. And then islice is basically just like slicing a normal string, except it works for iterables in general. Slicing is when you do something like this, like that. So you can't do that on an iterable by default, but islice allows you to do something analogous. So by combining these, we can take a input key and repeat it forever, and then take that and slice it down to the size of our plain text, which gives us something that we can XOR against the plain text to get our ciphertext. And of course, to actually do the XORing, we need to import bytes XOR. Now this will take a fair bit of typing, so let me go ahead and speed it up a little bit. Now this is implementing the function essentially the way I just discussed it. Note that islice isn't strictly necessary. We could rely on bytes XOR to truncate the key, but I'd rather not do that for clarity's sake. And there we go. It's actually just as simple as that. So now let's go ahead and add a main block that'll test the input and output provided by the challenge to make sure that we've actually implemented repeating key XOR correctly here. We'll copy in our plain text like so, and then once we've got that, we'll get our expected ciphertext. And I should probably mention this because I've used it in a couple places now. This syntax that I'm doing right here with adjacent string literals, this is something that you can do in Python to define a string across multiple lines without making it a multi-line string. Those are when you do triple quotes, like so, which allows you to do something that has new lines in it. But if you don't want the new lines, you just want to be able to spread your string out over several lines, then you can do what I've done here, which is to just put the different parts of it into individual string literals and then just put those adjacent to each other without separators. You can do this without the parentheses, but only if you escape the new line. If you don't escape that new line, then Python takes this to be the end of the current line and this to be a string literal on its own line, like a separate expression entirely, and it complains about the indentation for obvious reasons. However, if you escape the new line, then it understands what you're trying to do, and if you put the whole thing in parentheses, then that works as well. So that's what I'm doing here to get one string with all this data in it, and one string with all of this. And because this doesn't automatically add new lines, I have to specify one explicitly here myself. And what I'm doing here is printing the hex of the ciphertext because that's what we're given down here. So if you want to visually confirm that's correct, you can look at that. And then of course we're also explicitly checking that the full value is correct. And there we go, it worked. We are going to skip encrypting a bunch of stuff under this. I don't want to show you my .sig file or password file or anything like that. We're just going to go ahead and say this is left as an exercise to the viewer. So go ahead, write your own version of this code and go off and do all that. And when you're done with that, come on back for challenge 6.